Hey everybody, we're going to be talking a little bit today about interval notation, and this is something that will allow us to accurately describe the domain and range of functions, or just of relations, I guess, and specifically those that are continuous, not the discrete ones. We've been working on discrete ones. This will allow us to do it with continuous ones, the ones that are connected, okay? So before we start with interval notation, I think the most important thing is to understand the difference between inclusive and non-inclusive. So inclusive, which we'll be using, one of the terms we'll be using, is going to be specified with brackets. So inclusive means it's included. It's part of the set. It's part of the data set. Non-inclusive, okay, is going to be shown using parentheses, okay, and that means not included. And you'll see what I mean once we actually have a graphical representation of it. Interval notation is always the minimum value followed by the maximum value, okay, and it's going to be either bracketed or with parentheses based upon if that point is inclusive or non-inclusive. All right, so let's go ahead and start with a fairly straightforward example. Let's go ahead and make a number line here, okay. All right, we're going to start here. I'm going to say this is 0, 1, 2, 3, 1, 2, 3, and 1, 2, 3, 1, 2, 3. Okay, make these negative. All right, so let's go ahead and say that we have an inequality that looks like this. Okay, just like that. Well, it's not an inequality. It's actually it's a line segment, but yeah, well, kind of, sort of. You'll see what I mean. So we have this here, and we want to describe these values, right? So if I want to describe this data set using interval notation, I need the minimum value first and the maximum value last. So if I look at this on a number line, I know the minimum value will be the number furthest to the left. It's not -3 because that's not part of the data set. This is the smallest number as part of the data set. It's right here, and that's -2. So for this example, we're going to say -2. Okay. Actually, I'll put it in a different color. Hold on. I'll put this in red. I'll put it right here. So -2, and the maximum value is 1. So it's minimum followed by maximum, right? So it's -2, 1. And now we have to say whether or not it is included or not. So if we look at this, -2 has a filled-in circle, which means -2 is part of the solution. So we're going to put a bracket there. Now here, 1 has an open circle, so you can see it's all the numbers up to 1, but not including 1. So that would be a parentheses, and that would describe this data set. So it's -2 to 1, including the -2, but not including the +1. Let's try another example. Let's go ahead and we'll do something very similar. So 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It's a little sloppy, but oh well, what can you do? 1, 2, 3, 4, 5, negative signs. Okay. All right, so let's go from here to here. Let's go from -4 all the way to 3. And we'll connect those. Okay. So if I want to describe this data set, I'm going to go with the minimum value, which in this case is -4, right? So -4. The maximum value is +3, so it's minimum followed by maximum. And neither one of these is included. It's non-inclusive, right? Because it's an open circle, so it's going to be parentheses. And that's how you do that one. Okay? Let's try one more. Now, let's see here. So 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you can see it's pretty, it's not too hard to make a rough and ready example here. Okay. All right, so now let's do something like this. Let's go with, let's go all the way here, and we'll go to here. Okay. So try this at home, pause it, try it. So what's the minimum value here? The minimum value is -1. So -1. And what's our maximum value? Well, our maximum value in this case is 5. That's 5. So it's non-inclusive for the negative 1, so it's going to be parentheses, and this is included the 5, so we're going to put a bracket there. Okay? So these three examples are pretty straightforward, right? It should make sense. If you see a closed circle, it's included. If it's an open circle, it is not included. Let's try one where there's only one point, then there's an arrow going the other way. Let's try that out. So let's say we have 0, 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. Okay, so let's say we have something that looks like this. So it's a closed circle and it goes this way, and we have an arrow. So that's a little different, right? So we know what our minimum, oh actually before I write this down, take a second, try it, pause it. Okay. The minimum value should be pretty straightforward. It's just -2, right? That's our lowest value. So we're going to put -2. Okay. Now our maximum value isn't 5. I should make that a little bigger. So let me zoom in here so it's a little easier to see. Our maximum value is not 5 because it doesn't stop at 5. It actually keeps going. So if you're going this direction, you're actually heading towards positive infinity. So I'm going to write infinity there. Okay. Now this would be included because it's a closed circle. However, infinity you can never reach. It's actually a direction or a concept. So we put non-inclusive for that. If it was going this way, like let's do another example here. I'll do one more. Yeah, let's do a piece of paper here. So let's say, drawing here, zoom in a little bit. It's hard to see. Okay. One, two, three, 5. Okay, there we go. So let's say we start with this. We're going to start here. It's an open circle, and then go that way. Okay. So our minimum, oh, before I start, take a second to try it. Okay, the minimum value is going to be this direction. It doesn't stop here, it keeps going. So if this way was positive infinity, this is going to be negative infinity. So negative infinity is our lowest value. Our highest value is 3. This is not included because you can never reach infinity, so that's going to be parentheses. And then 3 is not included because it's an open circle. So that's how you would do that. Okay. So that's integral notation. That's how you'd express it on number lines. Now, how do we do that with with relations, connected continuous relations? Well, I'll show you. So here's a few examples here. Let's take a look at this one here. We'll zoom in. Actually, we'll do this one right here. Hold on. Okay. Yep. Let me zoom in a little better. So this is a function. We know this because it would pass the vertical line test. Let's also assume that it stops here and it stops here. Let's just do that. This one we're going to say there's stopping there. So we're going to do the domain, right? So how do you measure the domain using integral notation? Well, the lowest x value, now remember the x value is measured by the x-axis, which is the horizontal axis, so it's left to right, right? So from left to right. The lowest x value would be here. This point here is the lowest x value because it's furthest to the left. And the x-coordinate of that point would be -5. So we're going to say -5 is the, by the way, it's for the domain. Sorry, I should be specific. And then what's the maximum x value? So if I go all the way to the right, it's going to be +5. And those are both going to be included because they're closed circles. So it'll be a bracket. Okay? Oops. Let me so you can see that. There we go. Now the range, remember that's the y values. Those are going up and down this axis. So the furthest down we are right here. So that's our furthest y value downward. So this is -3, -4. So it looks like -3.5. So -3.5. And then the positive, the maximum, is up here right, all the way up top, that's going to be 1.5, it looks like, positive 1.5, and that'll also be bracketed, okay? Awesome. All right, let's try this one here. Now this one, we're going to change that to have this be, so it's right there, and this will be an arrow. So this is an arrow going up. Okay. So let's do the domain. It's a different color. So the domain is going to be the x value, so the furthest to the left. Remember, domain's going left and right. So this is how far left it goes. So -5. And that's a, might as well do it now. It's a bracket because it's included. It's a full encircle. Now the domain, it looks like it keeps going this way, and it's an arrow, so it's going to keep going to the right. So it's actually, I know it's going, it looks like it's a pretty steep slope, but it is going to keep going to the right forever, so that's going to be positive infinity, because it would eventually keep going all the way to the right, and that'll definitely be non-inclusive, because infinity and negative infinity are both non-inclusive, okay? All right, let's check out the range. Now the range is how much it goes up and down, or the vertical change. The furthest down we're looking at is here, so that's -3, and that's included because it's a filled-in circle. And the y value, well, it keeps going up, so it's going to be positive infinity, and that'd be the range. Okay. Let's do one more. Let's do one more of those. Let's do this one down here. Okay. So I'm going to make this have a point here, and there'll be an arrow going that way. Okay. So the domain is our x are the x values, right? The lowest x value is all the way to the left. There's an arrow, so it's going to be negative infinity, non-inclusive. And all the way to the right is 5, because it stops there. So it's bracket because it's a filled-in circle. So it's included, right? So range, remember the range is the x and y, sorry, the range is the y values. So the lowest y value is actually going to be negative infinity because it's going downward. It's going to keep going that way. So negative infinity, parentheses, because it's not inclusive, because it's an arrow, it's going in that direction. And then the highest y value looks like it's 4, and that's included because it's a filled-in circle, so it's a bracket. Okay? So with those three examples, right? With those three, let me zoom out a little bit. With those three examples, you should be able to use interval notation to describe the domain and range of continuous continuous relations. And then the basis of it is really these number lines here that we're using it for these segments. Okay? So I hope that was helpful. We're going to be spending time in class on Monday and probably Tuesday as well working on this. So let me know if you have any questions. Thanks, guys.